Hello everyone, let's try straight into automated testing for intelligent flows. The formal definition of automated testing in this context is the use of software tools to execute pre-scripted tests on a Power Automate flow to verify that its logic, integrations, and AI-driven outcomes meet specific requirements without manual intervention. In plain everyday English, it is like hiring a robot to double check your work every single time you change a light bulb. You see, when we build intelligent applications, they have many moving parts, connections to databases, AI models, and email systems. If you change one small thing, you don't want to have to manually click through the whole process to make sure it didn't break. Imagine you are running a local bakery. You've built a smart system that automatically orders more flour when you run low. Instead of waiting for a real low flour emergency to see if it works, you run a test that pretends the flour is empty. Stay with me here because automated testing is how we sleep better at night. You've probably seen this at the office where someone updates a tool and suddenly everyone's email stops working. Automated testing is the shield that prevents that disaster. Let's break this down together. We are building a safety net for our intelligence. So, now that we've mastered the idea that automated testing is our robotic safety net, you might be wondering how we actually fake the data to trigger these tests without messing up our real business records. Well, that brings us right into our next step, which is mocking data and triggering test runs. This brings us to mocking data. The technical documentation defines mocking as the process of creating simulated objects or data inputs that mimic the behavior of real system components, allowing you to isolate and test a specific flow's logic in a controlled environment. To speak naturally, it is the digital stunt double. You don't want to use your real expensive AI credits or your real boss's email address just to see if a button works. You create fake data that looks and acts like the real thing. Imagine a dummy example of a loan approval flow. Instead of using a real customer's social security number, you use a clearly fake one like 999009999. The flow thinks it's talking to a real person, but you are actually just playing in a safe test box. You've probably noticed at the office how some systems have a training mode. Mocking data is how we build that mode for our flows. Let's break this down together. We are using fake guests to practice for the real party. So now that we've mastered how to use stunt doubles for our data, you might be wondering how we tell the system exactly what a passing grade looks like, so it can tell us if the test succeeded or failed. Well, that brings us right into our next step, which is defining assertions and expected outcomes. Now we need to talk about assertions. The formal definition says an assertion is a logical expression that checks if a specific condition is true after a test step is executed, such as verifying that a variable contains a specific value or that a status code is success. In simple everyday English, it's the rule book for the robot. You can't just tell the robot to test the flow. You have to tell it what a good result looks like. Think of a dummy example. You are testing an AI model that summarizes emails. Your assertion might be, the summary must be shorter than 100 words. If the AI gives you 150 words, the robot flags it and says fail. Stay with me here because assertions are the brain of your test. They make the decision for you so you don't have to read every single log. You've probably noticed at the office how helpful it is when a form tells you exactly what you missed. Assertions are those red flags that keep our quality high. Let's break this down together. We are defining the winning conditions for our app. So now that we've mastered how to set the rules for what counts as a success, you might be wondering how we can run these tests automatically every single time we update our Sealbox solution. Well, that brings us right into our next step, which is integration with CI/CD pipelines. This brings us to continuous integration and continuous deployment, CI/CD testing. The technical documentation defines this as the automated execution of test suites whenever a new solution version is committed to source control or moved through a pipeline, ensuring that no regression errors are introduced. In plain language, it is the health scan at the border. Every time your Sealbox tries to move from your backyard to the live storefront, the pipeline stops it and says, wait, before you go live, I'm going to run all 20 of our safety tests. If even one test fails, the border stays closed. Imagine a dummy example. You are building a new feature for your customer support bot. You accidentally deleted a small line of code that helps the bot understand Spanish. You might not notice it, but the automated test for Spanish language detection will catch it immediately and stop the update. You've probably noticed at the office how professional it feels when a company fixes a bug before you even knew it existed. CI/CD testing is how they do it. Let's break this down together. We are making quality control automatic. So, now that we've mastered the health scan at the border, you might be wondering how we handle those intelligent AI answers that change a little bit every time and don't always fit into a simple yes or no box. Well, that brings us right into our next step, which is testing generative AI and non-deterministic outputs. Let's dive into testing generative AI. The formal definition describes of evaluating non-deterministic outputs, where the same input may produce slightly different text, by using evaluation models or similarity scores to check if the AI's answer remains within an acceptable range of meaning. To put it very simply, it is testing the vibe, not just the words. When you use GPT to write a polite email, it might use different words today than it did yesterday. You can't use a simple rule to check every single word. Instead, you use another AI to grade the first AI. Imagine a dummy example. You ask the AI to be warm and friendly. Your test checks, is this email polite? Does it mention the customer's name? If the AI says hello Sachin one day and hi Sachin the next, both are passes because the vibe is correct. You've probably noticed at the office how a good manager doesn't care exactly how you say have a nice day, as long as you are being nice. We are teaching our tests to have that same judgment. Let's break this down together. We are testing the quality of the intelligence. So now that we've mastered how to grade the AI's personality, you might be wondering how to look at the big picture to see if your tests are getting better or worse over time. Well, that brings us right into our next step, which is test reporting and analytics. Finally, we reach test reporting and performance monitoring. This technical area focuses on using dashboards to track test coverage, how much of your app is actually being tested, and pass-fail trends to identify weak spots in your intelligent flows. In our relaxed classroom tone, it simply means the digital dashboard of trust. You want to be able to show your boss a chart that says, we have 50 tests and they have all passed for the last 30 days. That is how you build a reputation for reliable intelligence. I've seen that the best builders are the ones who treat their tests like a garden. You have to water them, prune the old ones, and make sure new features are always covered. Imagine a dummy example. You see that your payment processing test has failed 3 times this week. Because of your report, you can go in and find the rusty gear before a real customer loses their money. Let's break this down together. As builders, we are the guardians of confidence. We've looked at the robotic safety net, the digital stunt doubles, the rulebook for success, the health scan at the border, testing the vibe of the AI, and finally, the dashboard of trust. We've mastered automated testing strategies. You now know how to build an intelligent app that stays smart and stays safe. Well, that brings us right into our next chapter.